Hello, everyone. Myself, Mallikarjun. I am a software engineer working in Barclays as a business intelligence developer, mainly focusing on building AI-powered solutions that drive smarter decision making. So my tech stack is using TechLixense, Tableau, SQL, data models, and cloud-based AI ML integration using Python. So mainly focusing on turning complex data into the actionable insights. So I'm here to discuss on the MLOps for the scalable BI and real-time analytics. Like it's a comprehensive guide to building, deploying, and managing production-grade machine learning system in financial services. So today agenda is we are focusing on five stages. So one is first one here we will start with the fundamentals of ML ops in financial services, then walk through the ML life cycle from injection to the deployment. After that, we'll look at the monitoring and governance and finally how all of this connects with the BI tools that decision making make us use every day. So we'll go through one by one. Yeah. Next one is the ML of maturity gap in financial services. That you can see the 83% of ML models in finance never make it to the production. That number should scare us. Why? Because it means billions spent on talent and platform without a business value. The reason are familiar. Compliance requirement that slow down the deployment, legacy system that resist integration, and the real-time performance needs that most pipeline can't handle. The big insight here, the bottleneck is in model development. It's everything that happens after, from building models to managing them. The reason is clear. It's not enough to develop a great algorithm. Financial banks need framework that automate audit trails, integrate models with legacy systems, and monitoring performance in real time. This is where MLOps comes in. Think of it as a bridge between model development and business impact. Automating the pipeline that handle deployment, logging, and compliance check. Whereas the next stage would be the versioning and monitoring tools so that it makes sure every model update is traceable. And if suddenly risk reviews that used to take weeks, it can happen in days or even hours. The point is, when you solve the after problem, all the investment in talent and technology finally start paying off. Model move from prototype to production, and business teams actually see the results. That's how we close the gap between building something amazing and making it useful. Yeah. Next slide would be the financial MI cycle. So it has multiple stages. So each stage has its financial twist. Coming to the first stage of data injection. So it is not just pulling the CSV files. You're streaming marketing data, injecting payment data, and even using the alternate data sets for that. Whereas coming to the next stage, featuring engineering, which is a critical for risk signals. Things like violating windows, credit utilization ratios, or liquidity metrics. And coming to the next stage, model training, which needs versioning and parameter tracking, but also regulatory documentation. Every decision needs to be explainable. Coming to the next stage is deployment. So model must be containerized, deployed via continuous integration or continuous deployment, and often tested with the required frameworks. And last stage is monitoring. This includes the drift performance metrics and compliance auditing and financial impact. So each stage has unique demand in finance, especially in the documentation and traceable. Coming to the next slide, which is a tech stack for ML ops for the FinTech. So I can go with a breakdown for the ML ops, like data engineering and the management would be the first task. Stage one, like data pipelines, like tools like Apache Airflow and Apache Spark, Kubeflow help building the automated data pipeline that handle data extraction, transformation, and loading the ETL to ensure high quality inputs data for the models. And within the same area, data versioning and tracking. Tools like DVC, data version control, enable teams to track data sets changes across the experiment and making it easier to reproduce and debug. modules. And another thing is like data quality monitoring, like ensuring data quality through validation tools like monitoring from helps detect issues such as missing values or anomalies that could degrade model performance, which comes under the data quality monitoring. Whereas like second, the other module is model experimental and versioning, which is nothing but experiment tracking like ML flow are used to log model hyperparameters, metrics, and configuration, and allowing those data scientists to systematically compare experiments for comparison. For the comparison, we use Neptune.ai, and within the same area, the model versioning are stored in registry like ML flow model registry, which documents the metadata, training data, and performance metrics for easy versioning and tracking the deployment. And coming to the deployment, so deployment with the CI/CD pipeline, like using automated module testing and validating and ensuring that all the modules are thoroughly evaluated before the deployment. This streamlines the continuous integration and deployment of the new models. And the scalable deployment, like containerization with Docker and orchestration using it is enable the flexible and scalable model deployments, which is nothing but adapting the resource to the real-time demands. And using the Bento ML and Amazon SageMaker is a fully managed cloud-based machine learning that provides tools and services to build, train, and deploy ML models. And the next stage would be the monitoring and maintenance. Like we are using evidently AI for drift detection and for the metric collections as well. Yeah. Next slide would be featuring engineering in financial data, whereas like some financial ML requires specialization feature engineering to capture temporal pattern market and the risk factors. So we're coming to the temporal patterns in finance, the timing of the events is critical. Generic features like average price don't capture the market pulse, but you want a feature that reflect how price and volume evaluate over the time, right? Let's say example, let's quote out short term fluctuations and highlighting trends. So short term versus long term MA can signal momentum challenges. So we're coming to the market micro strategy feature. This is nothing but this bit ask spread, that difference between buying and selling the price, which comes in the same area like depth imbalance and transaction cost and slip level. Coming to the next slide, CACD for the financial MI models, which is nothing but continuous integration and continuous deployment. Whereas coming to the data validation, every new data must be passed quality and bias check. Next stage would be model training. Training pipeline generates the documentation and risk reports automatically. And next stage would be the testing and staging, that can redeployment reduce risk before full rollout. Regulatory gates, which is the next stage, like compliance reviews are integrated into the pipeline, so approval aren't manual bottlenecks. CI/CD isn't just a DevOps idea; it's a governance frameworks in financial MI. So next slide would be the real-time interface architecture. This is where MLOps meets systems engineering, whereas low latency use cases like fraud detection, algo trading, instant credit scoring. If you are too slow, either fraud slips through or legitimate customer gets declined. So coming to tech stack solutions like optimization model or GPU acceleration and streaming platform like Kafka, sometimes even edge deployments, which takes a matter. So the other thing is like scalability pattern. To handle market payments to wallet, you need auto scaling clusters and load balancing and prioritization framework to keep core services stable in finance. And performance is not just nice to have, it's must that it should deal with it. And next would be the compliance and governance for the fintech. Okay, governance is the foundation, like model cards that compile with SR 11 by 17 and expandability report using shape and line. So version control validation artifacts, For audits, you need an immutable logs, reportable environment, and deployment histories. Security also matters, like encrypting a pipeline component and using the strict role-based account access and scanning container. Without these, like you can't have MLOps. So you have a risk exposure here. And monitoring financial ML in production. There are a few steps to track down in production for monitoring the machine learning. So that is nothing but track data and prediction drift. Over the time, your model input data and its prediction can shift, leading to decreased accuracy. So monitoring these drifts helps identifying when retraining is necessary. Watch for the training service crew. Ensure that the data used during training closely matches the data in the production. Significant differences can cause the model to perform poorly. Like next would be the monitoring data pipeline health. Issues in data processing can introduce errors or delays affecting data model's performance. Keeping an eye on these pipelines ensures smooth operation. The other would be evaluating model performance continuously, and which is nothing but backtesting and other metrics to access how we model in the perform in the real time conditions. So this helps in making informed decision about updates or retraining. And finally, the setup the alarm anomalies, implementing alert mechanism to quickly detect and respond to any unexpected changes in model behavior or performance. So by focusing on these areas, you can maintain the reliability and effectiveness of your machine learning models in production. Coming to the next slide, like concept driven drift management in financial model. Drift management in financial model is about detecting changes in data and relationship that can degrade model performance over the time. So it involves monitoring input features and model predictions using metrics like PSA or KL divergence to flagships. When drift is detected, models are recalibrated or retrained on recent data to maintain accuracy. So continuous monitoring and governance ensure the model stays reliable in dynamic market or credit environment. So next slide would be the integrating ML with the BI tools in finance, like integration approaches or like REST APIs for the model prediction and endpoints, and embedded Python or for in dashboard computation and pre-computed feature stores for the low latency access, custom visualization extensions for the model insights. To these capabilities that support the BI platform is Tableau, Power BI, Looker, and ThoughtSpot. Whereas this process for the integrating the ML with the BI tools in finance is predicative analytics, like ML algorithm or analysis historical data to forecast future trends such as sales or customers behavior and enabling the proactive decision making, and also automated the insights and enhancing the forecasting and detection and personalization recommendation. So that would be the integrating the BI tools with the MI. Next would be the NLP driven financial analytics, which is nothing but AI. At its core, like NLP technology is built on the interaction of computer science, artificial intelligence, and so main core components of NLP systems are like tokenization, parsing, and machine learning, which is nothing but break down text into the different individual words or passes, allowing systems to analyze smaller part of a sentence. Such words or shorter phrases is nothing but a tokenization. And the next would be the parsing, that understanding the grammatical structure helps system integrator relationship between words. And finally, the NLP model can generate more accurately by using the machine learning outputs by training with vast amount of text data. While additionally, data can enhance performance, model also need careful monitoring to avoid the degradation over the time. So, machine learning uses an algorithm to detect pattern in text, enabling the NLP system to identify and categorize data efficiency. This approach allows models to recognize recurring themes, sentiments, and entities within the text data. And key takeaways are like start with the when we design something, like start with the architecture, like designing machine learning ops pipeline with the specific requirement in mind from day one, and integrate early, connect the ML capabilities directly into the existing BI tools where users already trust the tool, and make it governance, and compliance isn't an afterthought. Build it into your auto workflows. Yeah, that's all. Thank you.